So let's start off by looking at it. So this is the platform where you get an overview of all the robots that are running in the field. Here you can see I have two robots, one in the UK and one here in the south of France, which if you look out through the window, you can see driving in the field. So if we look at that one first. So this is the robot that we actually have driving out here live. You can see we have the plan that it's driving. Over here we can see a visual of how much of the plan is done, how long it's going to take, how much is remaining, and how much is done. We can see the name of the field, the name of the plan, and the operator. This is really important, so when the plan is finished, the driver knows exactly where and when to pick up the robot and what to do with it. If you're surveying it in real time, you have the front camera here. Which is showing a live stream of the camera on the front of the robot. You can use this to monitor that it's driving in the right place, that there's no obstacles around it, and that there's no people around it. We also have a rear camera as well. Which is situated behind the front camera, of course, looking backwards so you can make sure that nothing's going on behind the machine. As well as this, we have the live telemetrics, which are coming off the robot. So you're getting data about the status of the engine. Sorry, there you go on the camera. You can see the implement got lifted up because it's just coming to a turn now. Yeah, so you see live data about the telemetrics of the engine as well. From here, I can also stop the robot if I need to. If I see that something wrong is happening, or if I want to pause it. So I can do a refilling of seed or something. My robot that's running in the UK, it's running a slightly different plan. We've got nice curved tracks here, following the line of the field. Here I'm just turning on the coverage so you can see the area that's already been worked by the robot. So again, this robot it's a very long plan it's doing. It's over 24 hours. The runtime on our robot is approximately 60 hours with a full tank of fuel. So we're very capable of doing large fields like this. It's been running for an hour and 30 minutes, and it's about 13% of the way through the field. We also have these secondary cameras, which are called our crop eye cameras. These are situated on the front of the robot, facing downwards. They're taking images of the crop, so that the farmer can, at a later point, go through and review the crop conditions, the weed conditions in the field, and can use them to make maps. But I'll get onto that when we're reviewing our operations. So as I said, the main purpose of the platform is to monitor robots, to create plans, and then to review the plans that have been driven. I'm now going to go on to talking about how we review the plans, because the creating plans part is quite intensive, so I'm going to leave that to later so that I can make sure I can fit everything in. So here, if I review the plans, here our farmer has these are real fields. They're not squares. They're not easy shapes. They're complicated shapes with complicated obstacles in them that we encounter in the real world and have to create plans for. This is some fields of organic maize where we were working all of these fields. So yeah, all of these fields. I'll take this one as an example. So under the fields, you can go into the plans and to look at the plans that we've created here last year. So this was the plan that we had plans for seeding, we had plans for cleaning. Roboti is very good at doing repetitive operations very precisely, the same every single time. So what we were doing here, we'd planted organic maize, and then we were using row crop cleaning to go through and take care of any weeds that emerged. So here you can see the plan. We've got headland plans where we're driving around the field, and then we're driving across the field in rows. Now, typically a farmer might choose to make the plan where he goes from one side and works his way across the field, because it's nice and easy to do, and that's how we were driving before we had GPS. However, now we're able to optimize the plans. So as you can see, the row order might not look intuitive, but it's been optimized, and we've actually got documentation that this can save up to 20% of the work time in the field. So we can offer very efficient operations. So this plan was driven a number of times. Every time the robot drives in the field, all its data is completely documented. And that data is split into two types of data. So we have the robot data, and we have the farmer's data. So the position, location of the robot, that belongs to the farmer. They keep that. If they sell the robot, they keep that data. And then we have all the data from the robot, the telemetrics, how the engine's doing, stuff from the cameras. That's all our data. So we can split that off so that we can handle the data separately. So if the farmer wants us to clear out his data, we can, but we still keep all the robot data. So as I was saying, this field was driven on the 28th of May with the cameras. So when the cameras are taking photos, we process them in the cloud so that we can analyze the pictures and see where the crops are and where the weeds are. Doing that, we're able to give an average crop count. So we can see here he's seeding somewhere between 5 and 6 maize plants per meter, and he can check then if that was his desired amount. You can also see the number of monocots and diacot weeds. And he can make notes here that it was a very wet day. So if I turn on our virtual field walk, so if the farmer doesn't have time to visit the field, he can review the pictures at a later date to see what's going on. So here, across the whole field, we have all these nice blue dots. The blue dots are exact places in the field where we've taken images. So if I just go into one here, then you can see the image from the camera. If I just turn on the enhancement here as well, we can look at what the model shows, and I'll just zoom in. So here you can see the model has analyzed the images, and we can see these large boxes where we've got our crop, and our small box in the center where we've picked out the actual emergence zone of the crop. So if you want to targeted application, targeted weeding, you can pick out the actual center of the crop. And then we have all our dicot weeds here pictured in blue. So what we're able to do with that is we can create maps. So here we can choose coverage and density maps for our weeds, for our crop. But if we just look at the density map, say of dicot weeds, and I'll turn off my dots. So here the farmer can see where exactly in the field that he has the major problems. So as you can see, most of the field here is quite clear. But here along the top edge, there's quite a high density of weeds. And here in the corner as well, there's also quite a high density, and along the bottom edge. So since this is where the farm is, and this is where the gate into the field is, there's a very good chance that the farmer might come into the field, just look around this area and decide, oh, I've obviously got a problem with weeds, I need to weed the whole field. But in reality, in the center of the field, there's actually very little weed coverage. So what he can do with our platform is take this map and put it back into our planner, and just create a plan where he's just weeding just in these special corners, which I have here. Yeah, so he's able to create a plan where it's only working in the places where he needs to. Doing that, you save a lot of energy, you save a lot of soil disturbance, you can save a lot of moisture in the soil as well by not moving it. So all in all, you can get a lot better operation by doing selective weeding where you need it. Okay, so I'm now going to go on to talk about how we create plans, since I've shown a few of them. All of the operations of the robot are done by creating the plans ahead of time. These are often done on the night before, so these aren't done in the field. So the farmer plans ahead of time what he wants to do and where he wants to do it. He's able then to review those plans to make sure it's exactly what he wants to do. So there's no surprises when he gets to the field. He knows what he wants, and he just goes to the robot and selects the right plan. If I choose this UK field, so farmers are able to upload their fields. They can import them as shape files, which they can either get from recording the field themselves, or from their other farm systems, or recording it from other tractors. We're completely compatible. You can also record fields with the robot itself, which is the safest way to do it. So once you've got your field, you then select your robot. I have a number of robots here, all of different sizes. So the plans are specific to the robot size. And then you can create an implement. Our implements are defined by the working width, the working length, and the offset from the GPS. So the width of the implement, the length, and our offset from the GPS. These are very typical for a farmer who's used to a GPS system. They know these from this is how you set up a tractor with a GPS. In doing this, we know exactly where the implement is, and we can put it into the ground where it needs to be. You can then do the settings for when it's in a working state and when it's in a non-working state. We can set the speeds, we can set the hitch height, and we can also set all of the hydraulics. The hydraulics can be, we have 3 hydraulic outlets on the robot. All color-coded. The bottom one can be used to attach to PTO as well. So you can drive PTO implements. The hydraulics can either be continuous while you're in operation, so you can, if you're doing a PTO, you want that to run continuously while you're working, or you can set it for a number of seconds. So if you're using it to open something out when you get to the start of work and then close it when you're at the end of work, you can do that as well. All completely controllable, all completely automated. Once you create implements, they're stored in your sheds based on implement type. I have one here, which I'm just going to take as an example. So then when we come into the field, we can decide what operation type we want to do. Farmers are extremely picky about how they want their fields worked. It's their field, they have the right to be, they've been doing it for generations, and they know what works. That's great for them, really complicated for when we're trying to create a system that follows what they do. So what our mentality has been, when we've been creating this system, we've got to fit into what the farmer wants. We can't tell the farmer, this is the way you're going to work your field. We need to create a system that they can use to create plans for working the fields the way that they want to. So we have a number of different operation types. We have headlands, where it creates circular headland around the field and then works across the middle. This is typical for wide acreage crops or any kind of lower value crops where you need to make the most of the whole field. We can also create turning area plans. That's when we have an area at the top and the bottom to do our turning, and then we're driving straight lines in between. This is very typical for vegetable crops, for higher value crops where you don't need to use every inch of the field at the top and the bottom, but you want to make nice straight lines across the middle. We also have transit rows, which are similar to turning areas, but just we can place them wherever we want to. They're not attached to the edge of the field. We can create bed systems as well, where we don't define how it drives when it's not in the rows, but we define exactly where the rows are. More typical for orchards and things like that. And we have calibration plans, but they're not important right now. So if I start off showing with a headland type plan, we can define how we want to then turn in the corners. We can do a fixed corner radius where we're turning the same radius all the time. We can do a variable where we do a bigger radius on the outside so we get better coverage around the turns, or we can do our zero turn where we drive into the corner, pick the machine up, and turn about our center and carry on for the best coverage. Again, it's completely up to the farmer what they choose. We try to be more constrictive to start off with only offering the most efficient ways to drive. But farmers will often choose the way that they want to drive, regardless if we tell them it's more efficient or not, which is, again, their absolute prerogative. So when we've defined how we want to turn, we defined the width of the headlands, and we defined where we want to start from. And then we have a number of other settings about how we work around obstacles, how we do turning points, such things. So let's look at the, these are the headlands. And then when we want to define the rows across the field, we can either define that with an AB line, or we can define it with a set of fixed rows. When we're doing an AB line, we can pull that in a number of ways. Again, each farm is different, so we've got to be able to accommodate all of them. We can put in a point and a heading, we can put in 2 points, we can click on the map, we can follow the edge of the field, or we can upload a shapefile from their own tractor system. If they've already done the seeding with something else, then they've already got their GPS line, so they just upload it into here and they can follow along. If I choose follow the edge of the field, very typical, we can put an AB line all along this edge of the field. And then give it a name. Of course, it's called AB1, as everyone else is. And then we can show how we generate that into... so now we have our field broken down. So that is a headland plan. If we wanted to do that as a turning area plan, we first pick our AB line. It's the opposite way around. We pick our AB line first. And then we have to select which areas of the field we want to use to turn around in. So it's all these blue areas around the field. We suggest it, but again, the farmer can turn off them as he wants. And then we can create our plan. Here we have the rows going across the field, and we're using the edges to turn around. Typically, we'll come out of the row, drive along the dotted line, and then drive into another row. Again, you can specify the width of those to be whatever you need it to be. Here we can define the driving pattern. So as I say, we're able to do a row by row, where we're just going up one and down the next. We can do optimized, where we do like a heuristic algorithm, where we choose the best way to drive across the whole field. Typically, that's, as I said before, 10 to 20% better than doing row by row. And then we have kind of a mixed method, which is grouped, where we take a small group of, say, 6 or 12 rows and do an optimized over those, and then do optimized over the next and optimized. So that is typically 5 to 10% better than doing row by row. We then have this coiled method, where we go up one row, down another, and kind of working across the field in a coil. This has the advantage of when you're driving, both sides of the machine are in the same conditions. So when you're driving, say, up like this, both sides of the row are unworked, the rows on either side of it. When you're driving down, when you're driving back up here, again, both sides of it are both worked now. So it's a more stable way of doing work, which can be really important when you're driving in soft soils. And then we have this back and forth, which is very similar to coiled, but it just works across the field and then works back. Yeah, so from here we're able to create our plans. If you can also go into the advanced options, where you can turn on and off individual rows if you want to. So yeah, you can decide which rows to work, which rows not to work. We can also enforce directions. So we have these nice little ducks, as we call them, on the rows here, and you can choose if you want to only work in a certain direction across a row. Again, in the real world, farmers will tell you, well, these 4 rows here can only be worked in this direction because of the slope or something. So, okay, well, we can bring that in then. We can follow what you want us to do. We can also select, we can create areas. So if this field had a wet area here, I can put that in as a parameter, and then I can either choose to make that a non-working area, meaning we drive through it, but we pick the implement up when we're doing it, or we can make it an avoid area, so that when we drive to it, we won't drive through it at all. We'll drive around it, so that there's no work done. So I see I'm getting near the end. I was just going to go through and show some interesting plans, but if anyone has any questions, I'd love to answer those now as well. Okay, so I can show some fun plans then. So working with the planner, we're able to, as I say, accommodate what a farmer needs to. This field, we've got multiple driving directions. Here you can see in the upper part of the field, we're following this edge of the field, and in the bottom part of the plan here, we're following this edge of the field. So we're able to create plans where we drive in multiple directions in the same field. I have a field here, very typical field again, with telegraph poles down the center of it. Great for communication, bad for route planning. So here we create the plans ahead of time, so we know that there's obstacles in the field, so we're able to plan for the robot to drive around them. Here the light blue area means it's not working, so we're able to create nice plans where we can drive all around these obstacles. Here is another field with many, many, many obstacles. So here, many obstacles that we have to drive around. So again, we want to drive as close as possible to those so we can work as much area, but also don't want to crash into them. So yeah, able to create nice plans where we're able to accommodate the organic fields that we're meeting in the real world. Here's another interesting field. Where we have some nice rows going across, having to use this small headlands here. Oh, sorry, yes.
So what about the slope? You know, what kind of field?
On slopes?
Yeah, what is the slope?
I think it's about 15 degrees we can work on. We have the implement on the center of the robot, so it's very stable. The weight is not all the weight behind, the weight is in the middle of the robot, so we're very stable. But I think we can work up to about a 15-degree slope before we start making a sound. When the slope gets too high, we start beeping, but we can still carry on working.
So thank you very much for the presentation. Sorry. I mean, thank you so much for the presentation. As you can see, it's this app or platform
Platform.
give a lot of information. So I'm sure here it's maybe farmers who want to buy robotic, but if you have to summarize all of the information you gave, what a farmer need to do to plan a mission.
Yeah.
Just maybe in 2 or 3 points, maybe just one step. It's the mapping. I mean.
Yeah. So once they've mapped out their field, taken the GPS top points, it's actually very simple to create a simple plan, which will get you started. But as every farmer knows, their field is unique. So using the features, they can hopefully manage to make it work in exactly the way they want to.
So one is the mapping.
One is the mapping.
Secondly, you
Creating
come
the plan
to
in
the
here.
you come to do the plan. You give all of the tool information, what work you're going to do, what tool you're going to do, you use, the speed and everything. And then that's all is the two main things you need to do to plan a mission.
And choose how you want to drive the field. So your AB line or
and the headlands.
Yeah.
So that's it.
Yeah.
So quite simple.
Yeah. And the plans then are delivered wirelessly to the robot. You don't have to, no USB sticks. The moment you create it on here, it's pretty much instantaneously available on the robot.
Excellent. Any question? So thank you very much.
Yep.
So if you have some more question or if you want to see robotic in real demo, so they are in the field. The demonstration will be this afternoon. So you will be presented the robot, and you will be able to see robotic in demonstration. So thank you very much.
And I just have the code here, the QR code, and the website address if you want to download an example version of our platform where you're able actually to view this robot driving in live.
Excellent. So thank you very much.